Welcome back to the Snap tutorial series. In this video, we'll demonstrate how to create a platform that connects to a remote calculation server for running job submissions from external sources. We'll guide you through generating a server key and exporting public keys from the remote machine, which users can then assign to their defined platforms. In addition to covering platform configuration and key generation, this video will also present a practical example of submitting a long-running uncertainty job to the remote calculation server. Before we get started, let's first explore what a platform is and why it's beneficial to use this tool. In addition to this, we'll show you the basic setup you will need in order to follow along with the example. Platforms refer to computer systems where applications are executed. Each platform is defined as either a calculation server or a high-performance computing environment, such as a cluster located remotely. Platforms allow users to submit lengthy or resource-intensive jobs to be executed on a remote machine, ensuring that the local computer remains free for other tasks during the process. User machines connect to the remote calculation server using a public key generated by the host machine and a specified platform location. The host machine initially generates a server key that acts as the private key and then exports the public key to the entirety of the users that need access to the server. This setup allows analysts to continue their work without waiting for lengthy runs to complete. To follow along with this example, ensure you meet the following requirements. You'll need two machines, one acting as the client and the other as the host. The host machine will serve as the remote location where our calculation server will run and where the key generation will be handled. Additionally, you'll need a client machine to define a platform, connect to the host, and submit a large uncertainty case. Both your client and host machines must be running Snap version 4.3.0 or higher with a trace and Dakota application defined within the host's available applications. In addition, both machines must have versions greater than or equal to Trace Patch 9 and Uncertainty 183. Open the configuration tool and navigate to the platform category within the navigator. When right-clicking the platforms category, the user can either import a platform or create a new one. Clicking New will prompt the user with the platform creation dialog. Here, the user can specify various properties of a platform, such as platform name, site name, architecture, platform type, and platform location. The platform name is a short, human-readable identifier for the platform. It is used as the second part of the platform ID and must be unique. A valid platform name only accepts letters, numbers, and underscores. The site name is another short, human-readable identifier, this time for the location where the platform is situated. It serves as the first part of the platform ID and specifies the name by which the platform will be identified. Like the platform name, a valid site name only accepts letters, numbers, and underscores. Architecture refers to the type of operating system the platform uses. Available options include Windows, Unix, and Mac OS X. It's crucial to specify this correctly so that the stream manager uses the correct line endings when writing files and the appropriate file path separators when locating files. The platform type indicates the platform module used to manage access. This could either be a calculation server or one of the HPC-specific platform modules loaded by the configuration tool at startup. For our example, we'll select a calculation server. The platform location is defined by the platform module. For a calculation server, this is the host name and port where the server can be accessed, in the format hostname. For other platform types, this value is interpreted according to the specific platform module selected. When calculation server is chosen as the platform type, a server key option appears in the dialog. This option allows you to select the public key that grants access to a remote machine. This brings us to the process of generating a private key for our remote calculation server and sharing the corresponding public key with machines that require access to the server. To generate a server key, navigate to the Configuration Tools File tab and select the Generate Server Key option. It's important to remember that generating a new server key will invalidate the previous key, rendering all currently exported public keys invalid as well. To export the new public keys, use the Export Public Keys option within the File tab. This action will create a public key that can be shared with users who need access to the server you've just set up. To enable a calculation server to accept remote connections, go to the Personal Settings category within the Configuration tool and set Allow Remote Connections to Yes. Note that the server port number will be crucial later, as it is referenced in the platform properties. To begin our example, we'll first need to start and configure our remote calculation server to accept remote connections and create a staging location to contain our generated run information. This example will run our remote calculation server in another Linux environment. This is only important during the platform's initial setup because we must specify the operating system type for the remote calculation server. The operating system you use to run the calculation server doesn't have to be Linux to complete this exercise. Using the host machine, we'll start by running the configuration tool separately from the model editor to initialize our calculation server and enable remote connections. In addition to allowing remote connections, set the port number to 5011. Navigate to the File tab and select the Generate Server Key option. If a key has previously been generated, override the current key within the dialog provided. Next, select the Export Public Key option within the File tab and name the key example_key. This key must be sent to client machines to allow them to connect to the calculation server. It's essential to understand that this key grants you access to your remote location and should be shared only with those who absolutely need it. If you have not set up the applications within your host machine yet, you can do so by clicking on Applications within the Navigator and creating your Trace and Dakota Uncertainty applications. After you've created the public key, navigate to your home directory and create a folder named Runs and mount it as the root folder. We can mount this folder by running the job status interface separately from the model editor and selecting the Runs directory as the root folder when right-clicking the Navigator and selecting Mount Root Folder. This folder will serve as our staging location and will be assigned later. Once the staging location is created and the key is sent, start up the host calculation server and go to the client machine that will define a platform and assign the public key. Using the model editor, open the lengthy_run_example model included in the video description and start the configuration tool. Within the configuration tool, create a new platform. Set the platform name to example_platform and site name to example_site. Set the platform type to calculation server and enter the appropriate host name in the hostname field, with 5011 as the port number. Next, using the key that we exported from the remote machine, assign it to the server key entry within the platform creation dialog. Save your changes in the configuration tool, then navigate to the uncertainty_stream job within the available job streams. Set the platform to example site example platform. Once the platform is set to the remote location, you'll notice that the stream steps now have their applications set to the remotely defined applications. If everything has been correctly configured on the remote server, the platform should be set up successfully, with no connection errors reported. Finally, right-click the uncertainty_stream job and submit it to the desired platform. Congratulations! You've successfully submitted your uncertainty case to the remote server, freeing up your CPU for additional work. We can view the results from the run from our local job console by navigating to the desired platform and connecting to the remote server. Once connected, we can see that our stream directories are located within our previously defined runs directory.